Okay, on tonight's edition of Homework Help, we are going over what's the point. I'm going to be doing questions 2, 3, and 6. All right, so question 2, they're asking you to answer questions about this quadratic function. Okay, so it says, first of all, it wants you to find the vertex. Remember the vertex, so what I like to do is I like to go through on the graph and identify all the important stuff. The vertex is where my graph turns around and starts going the other way, and that happens right there at the vertex, V for vertex, okay? I also like to identify my x-intercepts and my y-intercept, okay? So I have my zeros or x-intercepts, my y-intercept, and my vertex identified, okay? So the vertex is right here at this point, which is -1, -9, okay? Is it a maximum or a minimum? So a maximum is an umbrella. Okay, so this would have a maximum because it has a highest point that it can reach, so it's like an umbrella, okay? A minimum is like a bowl, where I have a lowest point that I can go. Obviously, the bottom of the bowl is the lowest lowest fluid can go. It's not gonna, it's not gonna suddenly start dripping through the bottom of the bowl unless something has horribly gone wrong, okay? So when you look at the shapes of these, if you see an umbrella, you have a maximum. If you see a bowl, you have a minimum, okay? I see a bowl here, so that tells me I have a minimum, okay? Now, when I look for the axis of symmetry, remember the axis of symmetry is a vertical line that goes right through my vertex. So there is my axis of symmetry, okay? So I'm going to actually label that AOS, okay? Since it is a vertical line, I'm going to use VUX to figure out what my equation is. So it's going to be an x equals equation, and it's going through -1, -9. Well, for an x equals equation, I look for the x part of that equation, x equals -1. Therefore, the equation of my line is x equals -1. All right, so that's how I find the equation of my axis of symmetry. Now, where does it cross the x-axis? Well, as I can see here, it crosses in 2 points. It crosses here at -4, 0, and it crosses again over here at 2, 0. All right? Now, it says list 2 pairs of symmetric points. Well, I see, now, there's lots of symmetric points, okay? I'm going to grab a different color for this just so I can kind of have a little bit of variety here. I see a set right there. I see a set right there. I see another set right there. And there's more, right? I mean, our graph, our grid only goes up to here, but if our grid kept going, we'd see more and more symmetrical pairs, okay? So the first symmetrical pair I see is at -2, -8, and 0, -8. Okay, what else is 0, -8? 0, -8 is my 0, -8 is my y-intercept, so I'm going to go ahead and write that down there too. Let's kill 2 birds with 1 stone. The next thing I see this pair right here. This pair right here is at -3, -5, and at 1, -5. And then we also have this. This is also a symmetrical pair, symmetric points. So technically also, I have another set at -4, 0, and 2, 0. Okay, so technically that's also a symmetric point. All right? So again, all we're doing on this graph is we're identifying the critical information. We're identifying our vertex, our axis of symmetry, our zeros, our y-intercept, and some symmetrical points. Okay? We want to know if it's a minimum, which would look like a bowl, or a maximum, which looks like an umbrella. Okay, let's take a look at number 3. Now, number 3, there's this table. You don't have to do anything with that. I'm not even really sure why it's there. I'm not going to lie to you. But we do want to go ahead and plot the points. Now, just for grins, let's see what we can find without plotting the points. Okay? So I saw a lot of people today while they were working on this, like, they would connect up these pairs and then pick the wrong value for the vertex. The vertex is surrounded by symmetrical pairs, but it doesn't have a partner. So if I connect up these points, and there's this one in the middle, this has to be my vertex. Okay, it has to be. Now, when I want to find my x-intercepts, my y has to be 0. So this and this are x-intercepts. When I want to find my y-intercept, it starts with 0. So y-intercepts start with 0, x-intercepts end with 0. Okay? So right now, I know the vertex is at 3, -4. I know that the axis of symmetry is a vertical line, so it's going to be a v, u, x equals, and it goes through the vertex, so x equals 3. Okay? I see the x-intercepts just by looking at the graph. 1, 0, and 5, 0. I know the y-intercept too. The y-intercept is here at 0, 5. Now, I can see one pair of symmetric points is 2, -3, and 4, -3. But today we practiced in class building out the table. We know that 5 has a partner. Okay? And we know that if we continue this pattern out to 5, we can find its partner. So 1, 2, 3, 4, 5, 6. So we also know that we have another pair of symmetric points at, what is that? 0, 5, and 6, 5. Okay? And hey, look at that. What point is symmetric to 0, 5? 6, 5. Okay? All right, let's look at this last one. Now, I had a lot of questions about this today, understandably, because we're talking about the quadratic parent function. I haven't really talked about that. So let's talk a little bit about the quadratic parent function. The quadratic parent function is y equals x squared. So if I were to make a table, well, first of all, when I put this in my calculator, I have to be, I can put it in here. Oh, come on, buddy. I can put it in here in y equals, and I can put x, so I hit the x button, and then I hit this squared button, and that gives me x squared. And I can look at the table. So the table shows, so let's just do -2, -1, 0, 1, 2, just because that gives us some negatives, some positives, and 0. Well, at -2, I have a value of 4, -1 is 1, 0, 1, 4. So I have a point at 0, 0, a point at -1, 1, a point at positive 1, 1, a point at -2, 4, a point at positive 2, 4. Okay? All right. Now, is it symmetrical about the x-axis? So what that means is the x-axis my line of symmetry? Well, no, because that would mean that it would have to be folded like this. If I fold it over like this, it's not symmetrical. So this is not right. Is it symmetrical around the y-axis? If I folded this in half across the y-axis, would it be symmetrical? That sounds good to me. It says the graph has a maximum point. Well, maximum means umbrella. Do I have an umbrella? No. I have a bowl. The graph has symmetric points, -3, so -3, -9, and +3, +9. That can't be right because those are under here and I have points up here. So that's not right. We will make a poster tomorrow of the quadratic parent function just so that you have a little bit more information. But that's what the quadratic parent function is. You're going to graph y equals x squared and see what happens. Okay, so if you have any questions, make sure you keep them for me for tomorrow, and I will see you then.